Hello everyone, I'm Edward Lin. Today I want to talk about how to make a neural network. Um, Today this course is told you how to build a neural network to recognize the handwritten number, which is an interesting task because we all know that the handwritten number is a little difficult for the computer to recognize because it's fuzzy, ambiguous, and is no a fixed, exact mathematical process. So how the computer can do this? How the neural network can recognize all these numbers? So let's uh, let's begin our course. Uh, our course is divided into three parts. In the first part, we don't talk about how to code the neural network. We have to understand how the neural network work, the mathematical the idea behind the neural network, and the the core idea of the neural network, the concept, basic concept of the neural network. In part two, we have to implement the neural network with Python, which is easy. In part three, we have to improve the neural network by adjusting the parameter or add some new techniques to improve the whole neural network. And we also will look inside a trained neural network to see whether we can understand how what the neural network have learned and to get some insight about how the neural network achieve its answers. Okay, neural network, the basic element is a neuron. So for neuron, they receive the multiple inputs and then address the inputs with the weight and sum up the input or the input, and then in order to avoid the to output the long noise. So they just apply some threshold function to the adjusted input and output y. So this is the basic how the neuron works. And in this course, we have an example. This is three level. Each level have three nodes. It's a network. This is this kind of network, and they just this level just receive the input signals and fill these signals through the neural network and then arise the output. So we can see that there's nodes in each levels and between adjustment levels between adjustment there's links connections between each nodes. Actually, each node in the level 1 is linked to the all nodes in the level 2, and each node in the level 2 receive links from the nodes in level 1. So it's the complete link. And then in between the level 2 and level 3, they also have this kind of link. So and there's a weight on each link. So basically, the weight is the heart of the neural network because this is where the learning happened. Let's see an example. See how the singles pass through the neural network, how we calculate the singles. Actually, this we get this we give you these two levels. Each levels have two rows, and for the row 1 in the level 2, the input singles is calculated like this: x equals input 1 times w11 plus input 2 times w21, and the row 2 in the level 2, the input single is calculated like this: x equals input 1 times w12 plus input 2 times w22. So this is how we calculate it. So we can use the matrix while convenient to do this kind of calculation if we have more rows, more levels. So let's see an example. If there's an input, the input of the row 1 in level 1 is 1.0, and the input of the row 2 in level 1 is 0.5, and the weight of the W11 is 0.9, the weight of W12 is 0.2, the weight is the W21 is 0.3, and the weight of 22 is 0.8. And then we calculate use the formulas. We can calculate that the input of the no one is 1 times 0.9 plus 0.5 times 0.3, which gives it okay, it is like it should be 1.05, but it outputs 0.7405. This is because we have applied the activation function on the row 1 before it outputs values. And the same thing happened in the row 2 in the level 2. So this process we call we fill the singles forward through the neural network. This is a forward process. But actually, before the neural network is well trained, the weight should be updated to minimize the errors of the neural network, of the output that arises by the neural network. Because neural network need to be trained to update the weight, we use the error to indicate how we update the weight. So let's assume that we have an error 0.8 in the output of row 1. So we have to reverse the whole process to calculate the error of the row 1 in a hidden level, which it just gives us is a 0.45, a 0.42. And how we split these errors? We just use the weight. We use the weight again to split the errors. So in the weight W11 is 3.0, in the weight of the W21 is 2.0. So we split proportional to the weight of the link, and we just split into aside 0.252 to the link of W11 and to the 0.168 to the link of W21. And then we calculate the end of the input level of the row 1 in level in row 1 input level. So this is kind of called we call the end propagation. So this is a backward process. So this is basically how the neural network, the basic ideas of the neural network. Actually, in which the weight plays an important role in the training process. So in during we calculate all these numbers, we use the matrix multiplication. Why we use the matrix? Because if you study the matrix before, you will see that if value it can express the large number of calculation in a very concise and very efficient way. And more importantly, some computer programming language understand how to do matrix calculation efficiently and quickly. So this is more convenient for us to use the matrix. So and in the process of back programming errors, we have to remember that we address the weight by the error. The error is the difference between the right answer given by the training data and the neural network's actual output. In the output law, the error is simply the difference between the desired and the actual output. And we just split the output level error in proportion to the size of the connected link weight, and then we combine these bits at each internal nodes. So this is this is the points which are cancelled when we back propagating the errors. So basically, what we do in the training process is just find the minimum value of the error, which we can the error is actually is a function of the weight. So we have to address the weight to minimize the error. So we derive a weight to how can we to find the minimum value of the error? So we use the gradient descendant technique. This is a really good approach for us to figure out the minimum of the function, because the end function of the end function is really complex and difficult for us to figure out directly from the formula. So we just use this kind of use this kind of method, the gradient descendants. It's very easily. In addition, this method is also resilient to the imperfection in the data, because if you use this way, if you if a step is wrong or if a data is imperfect, it can be overwritten by the next or corrected by the next steps. So this method is resilient. So for the weight update, we use we should be consider some factors. So it just said that the neural network's error is a function of the internal link width. So we have to improve if we want to improve neural network, we have to reduce the error by changing its weight. And so we have to choose the right weight directly. So, but if we but it is difficult for us to choose the right weight. So we have to assign the neural network initial weight randomly, and then we just address the weight using some technique called gradient descendant to make it the error smaller and smaller. So this is the weight update. Actually, this is the formulas we use. We use n function. Is we use the n function is that is so we just do the a derivative of n function and we get these formulas. This formula is very useful in our coding, so you have to remember it. And if you want to know more details about this, how we get these formulas, you can see the books that make your own neural network. Here's some tip. Actually, there's a lot of contents, a lot of points you should be paid attention to when you build your own neural network. Here I just give you some tips about how to do neural network well. Firstly, the neural network don't work well if the input, output, and initial weight data is not prepared to match the neural network design and the actual problems being solved. So you should take care of this. And second, the common problem is the saturation, where large singles sometimes driven by large weights lead to singles that are at very short of the slope of the activation function. It reduces the ability to learn better weights. Third is another problem is zero value singles to weights. It also kills the ability to learn better weights. So we call them input the zero value singles or weights because it doesn't work. And we have to assign the link weight randomly and small because if we assign the link weights with the same number, they will lead to a disaster. And the input should be scaled to a small but low zero. A common range is 0.01 to 0.99. So minus 1.0 to positive 0.0. It depends the problem we solved. And then the output should be in the range of 0. It should be in the range of 0.01 to 0.99 because there's an active wave function that could output some values below 0 or above 1. So keep it in mind. This is the tips. So the what I told you previous what I told you just what I have told you is that the basic idea of the neural network. So we will discuss how to code the neural network in the next course. Thank you.